All right. So today we're doing electron configuration, which if you look at our poster up here, this is skill number 3, and then we're going to do the noble gas configuration, skill number 4. So we're covering 2 of them today. All right, so the first slide here is there are 4 blocks to the periodic table. 4 blocks. There's S, P, D, and F. So your S block is the first 2 groups, groups 1 and 2. D block is groups 3 through 12. P block is groups 13 through 18. And the F block is down here, those intertransition metals. So what I would do right now is pull out your pink periodic table and write down, like maybe bracket and put S is right here, D is here, P is here, and F down there. So label your periodic table, because that's what we're going to be looking at when we do this, not necessarily at just this slide. So S block, D block, P block, and F block. Now for the sake of what we're going to do right now, where I talk about how to find the electron configuration, we're going to take helium, which is this element right here, and we're going to pretend like it's over here. So we're going to forget that it's in this place and pretend like it's over there beside hydrogen, just for the sake of this electron configuration, figuring it out. Okay? So you don't have to permanently move it on your periodic table or nothing, but just for the sake of this, maybe just on your notes. Yes?
Does the block go all the way to the...
No, it stops right here.
Okay.
Yeah.
Maybe you don't count the one on top of it. You don't count the one.
You don't have to. You don't have to like X this out or nothing on your periodic table. I mean, helium is still over here. Just for the sake of what we're about to do, we're going to pretend like it's right there. Okay. All right, everyone got that written down? Okay. All right, so electron configuration. It's exactly what the name is. It's the configuration of the electrons outside the nucleus. So electron configuration is the arrangement of electrons outside the nucleus. So it's going to tell us, where do we know electrons are? We know they're in the electron cloud, but more specifically, where do we know they are? They're on what? They're in orbitals, that's one thing. What else? What did Bohr come up with?
The rings.
The rings, which are called what? Energy levels, yes. So, we know energy level. This is going to tell us energy level. And it's going to tell us orbitals, which we haven't really got into orbitals yet, besides the Schrodinger presentation, but we're going to get into that tomorrow. So energy levels and orbitals. That's what it's telling us. Now, can we really tell where these electrons are? No, but this is the best guess we have. Okay, so how to find it. All right, first we're going to talk about how to find, which I said won't make very much sense. All right, but then I'll talk about what it means, and then it'll all come together, okay? So when we write electron configuration, we have a blank, and an exponent, okay? This first blank right here is going to be our period number. And is a period on the periodic table a column or a row? Row. So here we're talking about the row number. So we know that's going to be a number. So we'll do an example here in a second. All right, the second blank right here. This is going to be what block of the periodic table it is. So what are your 4 options?
S, D, P, F.
Yep, S, D, P, or F. So the second one is going to be what block of the periodic table we're in. And then this exponent is going to be the number of elements counted left to right. So the number of elements we count left to right. So we've got the row number, the period. We've got the block, S, P, D, or F. And we've got the number of elements that are counted from left to right. Okay? So find oxygen on your periodic table. Find oxygen. Alright, so what period is oxygen in on the periodic table? 2. So this first one would be a 2. Alright, what block is oxygen in? S, P, D, or F?
P.
P. Alright, and then starting right there at your P block. So P block right here. How many elements do you have to count over to get to oxygen from left to right?
4.
1, 2, 3, 4. So our number here would be 4. Questions on that so far? Everybody still with me? Good? Okay. Alright, but for electron configuration, we don't just go pick the element out on the periodic table. Alright, so where do we start with electron configuration? We're always going to start in the top left corner of the periodic table. So, top left corner of the periodic table. So it's like reading a book when we do electron configuration. We're going to start in the top left-hand corner of the periodic table, and we're going to work our way across and through each row till we get to the element that we want to stop at. Okay? So let's do oxygen's electron configuration. Let me go to the periodic table I have. Alright, so we know that we're stopping at oxygen here. We're pretending like helium is right here for the sake of this. And this is our S, D, P, and F blocks. Alright, so for oxygen. Alright, we're going to start right up here. So what row number am I at? What row is this right here? 1. What block is this? S. And how many elements are left to right here? 2. 1s squared. Now I would keep going across, but there's nothing here. So now we go to the next line. What row am I at? 2. What block is this? S. And how many elements are there left to right? 2. Alright, but we're still not to oxygen yet. So now I keep going across. What row am I still on? 2. But now what block am I in?
P.
P. And how many do I count to get to oxygen? 4. So the electron configuration for oxygen would be 1s squared, 2s squared, 2p to the 4th. So we're following the periodic table like a road map. What's the other element that's on that slide for the example?
It was, I think potassium.
Potassium, okay, let's do potassium. So now let's do potassium right here. Oops. Didn't mean to put that button. There we go. Alright, so we're doing potassium. Alright, so it's right here. But where do we start? Top left, up here. Alright, so what row am I on? 1. What block? S. And how many elements? 2. So 1s squared. Then I would keep going over. There's nothing there. So next line. Alright, what row am I on? 2. What block? S. And how many elements are there right there? 2. So 2s squared. Alright, now we keep going across. What row am I still on right here? 2. But what block? P. And how many elements total across? 6. So 2p6. Alright, next row. What row am I on? 3. Block? S. How many elements? 2. So 3s squared. Keep going across. What row am I on? 3. What block? P. How many elements across? 6. All right, we're almost there to potassium. So what row are we on? 4. What block?
1. Oh, S, my bad.
S. And how many do we have to count to get to potassium? 1. So 4s1. So the electron configuration for potassium: 1s squared, 2s squared, 2p to the 6, 3s squared, 3p to the 6, 4s to the 1.
Do we put S instead of 3?
No, because the 1 is gonna, we're gonna talk about what it means here in a second. This is just how to find it. Questions on that part so far? Good so far? Alright. Okay, but next slide says, note, the D block starts on 3. So look, if we looked at the D block is here, right? It's this middle section. What row does it look like it starts on? 4. But the D block starts on 3. So on your periodic table, this is what I would write in. First of all, if you don't have the numbers over here, I would write those, 1 through 7. That way you're not having to count it each time you get there. You can just look at your number. All right, next thing I would write is right here on scandium, I would put a 3 so that you can remember that once you get to that D block right there, it's not going to be row 4, it's going to be row 3. All right, but then that's only the D block that's shifted down a number. So when we get back to the P block over here, we're back at row 4. So maybe on gallium, you might want to write a 4 in that box. So then we're at 5s here. So what row do you think this D block's going to be? 4. And then just remember that after you get through the D block, it jumps back up to its original row number 5. Now, I will not ask you to go any further than 6s squared, barium. And that's because after that, we have to go down and do the F block and do those, then come back up and do these. So we won't go that far. We'll stop at barium. All right, so does it have on your slides an example element? No. All right, let's do cobalt. Cobalt. So we always start top left-hand corner, and if you realize it's a pattern every time. You just gotta figure out where you're stopping at. All right, so this time we're gonna say it out loud together, and then we'll write it afterwards. I want you guys to all chime in with me. We're gonna go slow, okay? Like 1s squared. So I'll even write the S back up here, the P, and the B. Okay? All right, so we're stopping at cobalt. All right, starting up here. All right, ready, go. 1s squared, 2s squared, 2, whoa, stop. There are people, A, not looking, B, not moving your mouse. We will write this after. Everyone is saying this out loud, or you will say it out loud by yourself. Okay? Ready? Let's try it again. Let's try it again. In unison this time, okay? Everybody.
We're restarting.
We're starting back up here. Restarting for all the people that didn't start in the first time. All right. Ready? Go. 1s squared, 2s squared, 2p to the 6, 3s squared, 3p to the 6, 4s squared, 3d to the 7. There we go. For all the people that hadn't counted already. 3d to the 7. All right, so now let's write that. So put this as an example on that slide. We did cobalt. All right, so we had 1s squared, 2s squared, 2p to the 6, 3s squared, 3p to the 6, 4s squared, and then 3d to the 7. So that would be the full electron configuration for cobalt. Sorry. Tripping on this chair. Questions on how we got that? So you're just following the periodic table like a roadmap. Alright, so now let's talk about what it actually means. What it means. Alright, so in terms of what this, so far we've just followed the periodic table like a roadmap and wrote some random letters and numbers, okay? But let's talk about what these little sets actually mean. So this first blank, what it means, is going to be our energy level number. So this is our energy level number. So when we have the 1s, the 2s, the 3s, we're talking about what energy level outside the nucleus. All right, the second block is going to be our different shaped orbital. So there are 4 types of orbitals, S, P, D, and F. We're going to talk about those tomorrow and practice drawing them. But they're different shapes, and it's that region of space where you're most likely to find an electron outside the nucleus. So we'll talk about the different S, P, D, and F shaped orbitals tomorrow. All right, and this number up here is not just how many elements we're counting, but it's our number of electrons that are located there. So we find it by following the periodic table like a roadmap. But what it means is what energy level are we talking about? What orbital shape, so 3D region of space, are we most likely to find this electron? And how many electrons are located there? So that's the most accurate we can get with where our electrons are actually at. All right, so we had cobalt, which was 1s squared, 2s squared, 2p6, 3s squared, 3p6, 4s squared, 3p7. All right. First energy level has an s orbital with how many electrons? How many electrons are there? 2. And isn't that the most electrons that can go on the first energy level? 2? Yep, there they are. All right. Second energy level. All right, we have an s orbital and a p orbital. How many total electrons are there? 8. So here's 2, here's 8. Isn't that the most that can go on that energy level? The second one? Yep. All right, look at our 3 here. We have 3s, 3p, and 3d. So add those up. How many electrons is that?
11.
8 plus
15.
7?
Oh no, that's not 11.
15. So our third energy level is not filled. But why is the 4 up there? So we'll talk about tomorrow the Aufbau principle that says that electrons are going to fill lower energy levels first. And it just so happens that this 4s is lower in energy than our 3d. So when we would fill electrons, they would actually fill into the 4s before they would finish up that third energy level. All right, so that's what it actually means. We're telling what energy level, what orbital shape, and how many electrons are located there. All right, so let's do barium. The farthest I would ever ask you to go. So then you have the full pattern. So we're gonna stop here. So this is
Are we saying in unison?
Yep, we are. And then we'll write it after. All right, so everybody look up here, follow along. We're gonna stop at barium because that's the furthest I would ask you to go. So anywhere else is just stopping early, okay? All right, ready, go. 1s squared, 2s squared, 2p6, 3s squared, 3p6, 4s squared, 3d to the 10th, there's 10 here, all right, then 4p to the 6, 5s squared, 4d to the 10th, 5p to the 6, and then 6s squared. And that's the farthest you would ever have to go. So let's write that. So barium. Alright, we had 1s squared, 2s squared, 2p to the 6, 3s squared, 3p to the 6, 4s squared, then we hit 3d to the 10th, back to 4p to the 6, then we had 5s squared, down to 4d to the 10th, back up to 5p to the 6, and then 6s squared. So that's a lot to write, but the full electron configuration shows you every single energy level, starting at the first all the way up to the highest, what orbital shapes we have there, and how many electrons are located there, okay? So you ready for the shortcut way to write it?
Yes.
You gotta know both.
I'm not done.
So number 3 on your skills-based test on this poster up here says, write the electron configuration for any element. Check, all right? Now we're gonna do the shorter way, which is called the noble gas configuration, okay? And that's skill 4. All right, so noble gas configuration. First of all, where are the noble gases on the periodic table?
All the way on the right.
Yes, so what group number?
18.
Yes, so these are group 18 elements. So a shorter way to write electron configuration is saying, we know that those noble gases are stable. So if we use the full configuration of this stable noble gas, we may just have to add on a little bit more. So it's basically saying, it looks like this noble gas with this added, okay? So, we did oxygen, all right? Oxygen's full electron configuration was 1s squared, 2s squared, 2p to the 4th, all right? So to do the noble gas configuration, number 1, we're gonna go back to the previous noble gas. And then we're gonna bracket the symbol. So if I'm at oxygen and I want the previous noble gas, I go up 1 row and to the far right. So what would it be?
Helium.
Helium. If I was at cobalt, if I went up 1 row and to the far right, what would it be?
Argon.
Argon. What about tellurium?
Krypton.
Krypton. What about calcium?
Argon still.
Yeah.
Argon. So when you want to find the previous noble gas, you find your element, go up 1 row and to the far right, okay? So what is oxygen's previous noble gas?
Helium.
Helium. So we're going to bracket its symbol, He. All right, and now we're just going to continue from helium. So after helium, we would have 2s squared and 2p to the 4th. So for our smaller elements, it's really not much of a shortcut. So you just do the actual line that that element's on. So we started from here, helium, started from here, and then we did 2s squared and 2p to the 4th. So number 2 is to continue electron configuration from there. Here you go. You have your, oh, you said it. Alright, so does anyone want to do the full electron configuration for phosphorus? Anyone want to? Alright, Caleb's going to try. Alright, Caleb, what would we have here?
Phosphorus, so you'd start at zero.
The full one.
Oh, full?
At we're stopping there.
1s squared,
Uh-huh.
2s squared, 2p6, 3s squared, 3p to the third.
Perfect. Alright, so now find the previous noble gas for phosphorus. Neon. So we're going to bracket neon. Alright, and then we just do the next line. So what would we have left?
3s squared and 3p to the third.
3p third. So you're always going back to that previous noble gas. And starting from there. Alright, we did barium, which was very long. Alright, you guys already have that written down. You already wrote it. That's bariums.
You just have that memorized?
Well, yeah, it's a pattern. I'm sure you'll have it memorized after you do some of these too. Alright, so what's the previous noble gas for barium?
Xenon.
Yeah, because barium's here, so we go up to the far right. So we bracket Xe. And then we just do the next line. So what would the next line be? 6s squared. Much shorter than writing that whole thing. So for the smaller elements, it's not that much of a shortcut because you still got to write the majority of it. But for our larger elements, it is shorter. So for your test on Thursday, you have to be able to write the electron configuration for any element. That's the full one. And the noble gas configuration where you start from the previous noble gas. Now let me give you a shortcut way. If you've already written the electron configuration, which you will have on your assignment today and on your test, all right, when you want to find the noble gas configuration, just go to your last S in your electron configuration and cut it off before that. So in this one, if I went to my last S, what would it be?
2s squared.
2s. I cut it off before that, and that's what I write after the noble gas. All right, for this one, what's my last S?
3s squared.
3s. So I cut it off, and that's what I write for my noble gas. For this one, what's my last S?
6s squared.
6s. So I cut it off there, and that's what I write after my previous noble gas. So
That
kind of
makes
a little
sense.
shortcut to write your noble gas configuration. Okay? So it's always your last S group because that's the line that your element's on. Questions? Alright, Jathan, can you turn that camera off right in front of you?